So a linked list, it is a way to store data, and each piece of that data, which we call a node, has two things. First, the actual data you care about, and second, a pointer or a link that tells you where the next node is. Now here's the difference from arrays. In arrays, everything sits neatly in a row inside memory, but linked lists? Nah, they don't care about that. The data can be scattered all over memory, and the pointers are what keep them connected in order. The good part? It's super easy to add or remove things. The not so good part? If you want the fifth item, you have to walk through nodes one by one, no instant access like arrays. Alright, here's what a node actually looks like in C. You've got something like this. The data is our value. The next is the address of the next node. Pretty straightforward, but this tiny thing is what makes the whole list possible. Let's visualize this. If we have an empty list, we just have a head pointer that points to nothing. If we add values 10, then 20, then 30, it looks like this. The head always points to the first node, and every node just points to the next until we hit null, which means the end of the list. So why even use a linked list? Well, here's the breakdown. Advantages: easy insertion and deletion. No shifting stuff around like arrays. Grows or shrinks while your program runs. Disadvantages: takes more memory because of that extra pointer. Slower to access specific elements because you have to walk through one by one. So remember, master this and you've got one of the core data structures in your toolkit. Something you'll see again and again in interviews, competitive coding, and real-world applications.